we're going over the X-ray computed tomography. I'll go over the history and purpose. Eric will go over the anatomy. So the X-ray CT scan was developed by Sir Godfrey Hughes Huntsfield, who received a Nobel Prize for his work. And the first patient scan was done in 1971. The first scan took about 4 minutes for each individual slice and took about 2.5 hours to process the image. A CT scan revolves around the patient to then take multiple slices of X-rays, which could generate a 3D image out of it. So the CT scans have increased dramatically in their use since its inception. You can see even from 1965 to 2005, it's tripled, and it's only increased since then. Major reasons for this is that with today's technologies, the individual scans take less than a second. I know when I had my CT scan, I was only in the machine for less than a minute. And they can give you accurate 3D images that traditional X-rays just can't achieve. So when you take a traditional X-ray, it's very easy for things to be hidden. So like if an object's above or below bone, it's just going to be overshadowed in a 2D image. But since an X-ray CT gives it multiple angles for a 3D image, stuff doesn't get overshadowed like that. Also, in a normal X-ray, while bone and metal shows very clearly, normal tissue is pretty hard to distinguish, which an X-ray CT can clearly see. The only potential risk is the increased radiation, since an X-ray CT is like taking multiple X-rays in one run. While some argue that the US is a little liberal in its use of CT scans, the general consensus is that the amount of radiation dosage from a single patient scan is well within the safety limits, even for a child. So then Eric's going to break down the machine.
I'm going to talk about the anatomy of the X-ray CT machine. So the basic parts is the spinning gantry and motorized platform. The spinning gantry is basically composed of the X-ray generator and X-ray detector. They're at opposite ends of the machine, and the motorized platform will just move the patient through the hole. So part of the X-ray generators, they're collimators. This is used to determine how widespread the X-rays are. It also shapes the beam. There are two types of detectors used in CT machines. It's one or the other. There's xenon gas and ultrafast ceramic. The xenon gas is it uses more dose, but is less accurate. It also costs less than the UFC. So this is the order of how the data shows up on the computer. First, it goes through the data measurement system, the DMS. It converts the signal into an analog signal, and then the analog signal is converted to digital data, and then it's finally refilled by the image reconstruction system. And this is just a picture. We can see the X-ray generator, and then the X-rays shine onto the X-ray detector, and the gantry will rotate at about 0.3 seconds per rotation. The patient aperture diameter will be about 2 feet, and the gantry will rotate at about 0.3 seconds. So it'll usually have 32 X-ray detectors. 32 X-ray detectors, and it'll scan in a helical path.
Okay, we'll go ahead and talk about the steps involved in taking an X-ray CT from a machine's point of view. Now, there's 3 required steps that you got to generate the X-rays in the first place, and the detector, and then you have to reconstruct the image. Now, this is a tube that you would find in anything that uses X-rays, right? Now, here, a little schematic here, you have this filament here that generates electrons, and the electrons just get accelerated to the targeted by the electric field set up by these things. And there's of course and the energy that comes in those photon electrons, the energy of those electrons just gets converted to X-rays. Of course, it generates a lot of heat in the process. You have this cooling process that needs to be done. And then once the X-rays go through the subject, it goes through this thing called a scintillator, which just takes the energy. When it's struck by ionized radiation, such as X-rays, it just converts to a visible like photon. Then you can just use an array of photodetectors to detect this visible image. And then you have electrons that send it to the computer for further processing. Now this is sort of, again, a sort of cartoon version of what you see here. It has the X-ray generator through the square target here. And what the X-ray detector sees is not the actual image, but what it creates what's called a sinogram here, right? Now, it looks nothing like this square here, but you can actually reconstruct the actual image from this. I'm going to do that a little bit. All right, so, and now the actual mathematical basis for this transformation is what's called the radon transform. It's actually related to the Fourier transform, but in this case, we're using it to reconstruct the image. Okay, it's just a line integral here, which is just, and here's one mathematical way to describe the geometry of the scanning. And then once you pass it through an algorithm to reconstruct the image from this sinogram, you get back this image here, which is the square root of 1. Another example, I'm going to show another example using the UCR logo here. I'm going to do a CAT scan on this, and you get this sinogram here, and here's a MATLAB code. You want to try this out yourself. So this is and then you can reconstruct this image, and this is what you get back. And so this X-ray CT computer basically just does this same thing, but in 3 dimensions. Of course, you also have some implementation issues, such as the algorithm has to be very fast because this is done in real time. Also, you need some filters because everything is noisy from the bioinstrument in real life. This is just, of course, in the perfect world of mathematics, you don't get an image that's as clear as that usually, so you have to apply some filters. And now, Michael will talk about why we use X-rays for.
Okay. We use X-rays for a number of things. I'm going to concentrate on the head, lungs, the abdomen, and the skeletal. Here is the CT of the head. When you look at an image, usually the denser the material, the wider and then when you look at it, usually you can tell when it's wider, you can see cancer, brain intrusions. Here we have a picture of a normal CT scan. Here is one that's abnormal. And here you can see when it's denser. Right here, the lungs are filled with fluid, and there's an enlarged heart. Here we can see that with the denser material, there is a tumor, and the lung is also it's thickened. Here is with the abdomen. Right here, you can tell that the material is denser, and this diagnosis is for alcoholic pancreatitis, and it's also used as a first-line detection of solid organ injury after trauma. Here, for skeletal trauma, you can see that in these images there is some fractures. Here is reconstituted a 3D image right here of it, which you can see better. And also, this is another example of fracture in the ankle and the foot.
Alright, so I'm just going to go over the patient scan procedure. So basically, a CT scan is it's a good test to use because it's not painful or anything like that. For the patient sake, the big part of the CT scan is proper preparation, and that preparation is pretty much what's going to be diagnosed in the patient. So basically, for the preparation, when you ask the patient to come there, you ask them to wear light clothes. You don't want them suffocating themselves or anything like that. To remove jewelry, as you see in this image right here, someone left the belly button piercing in there, so that sort of distorts the image and causes the X-ray beam to distort the image. In some cases, you ask not to eat beforehand or drink a contrast agent. From what Michael said before, the different diagnostic applications you can use for a CT scan, these are the different preparations that you might maybe asked to do depending on what is being tested. So for abdominal CT scan, you're asked to drink a liquid contrast agent, or you can also be injected with the dye. And for the head and chest CT scan preparation, you can also be given an injection of a certain type of contrast medium. And also for the pelvis. These are just a few examples. I'm not going to get into all of them due to time's sake. But as you see, this contrast is coming up a whole bunch. So what a contrast agent really does is it sort of enlightens the organs for the radiologist or whoever's looking at your CT scan to better visualize it. It makes it more visual for the person reading your CT scan. So basically some examples are iodine, barium sulfate, or an enema. And those are how they're administered right there, and I'll get into that right now. Is that these, usually there's only 3 different ways to be administered these different contrast agents, and that's orally, intravasively through an IV or rectally. So orally it's pretty much self-descriptive. You just drink something, take something like that. IV, you just get a small injection on your, usually your right or left arm, whatever they can get the best bang. And it's just to highlight the structure of the organs better, and rectally that's pretty self-explanatory. But basically, the CT scan, as Parker said earlier too, his was pretty quick, like a minute. The whole thing, like your whole going into the procedure room and coming out, it takes really quickly, under an hour, non-invasive. You can continue everyday activities. And also another thing I wanted to point out was you're asked to drink a lot of water to soften the blow to the kidneys. So you may be asked to drink like a barium sulfate contrast agent to better visualize your organs. And you don't want the barium in your system too much, or you don't want them absorbed by your kidneys too much. So that's why they ask you to drink a lot of water to make that absorption of the kidneys or that blow a lot less. But here's just an image of someone during a CT scan. Pretty simple, it's not painful or anything like that. The big part of it is the preparation and the contrast agent you take with that, or whatever preparation they ask. And that's it. Any questions?
And just,
we have about 10 seconds for questions.
Okay, in that time, we can show you an actual CT machine spinning around. And you can see it spins really fast. And so the person actually would go through here. And this is why we put the cover on, so we don't freak the patient out. And that's the end of that.